on this computer. Okay, welcome everyone. Thank you for joining the IoT Peoria meetup. We have these every month, and so if you don't belong, if you go out to the meetups and look for IoT Peoria meetup, please join the group. You'll get the announcements when we're having it, who the speaker is. Just helps you get connected in with the group as well. So again, thank you for being here. I'm very excited about our speaker today. We have Andy Wang here. He's the founder and CEO of Prescient, if I'm saying that correctly, devices. And he's going to be talking about the low code in IoT and also at the edge in AI. Dr. Andy Wang has his PhD from MIT, both in electrical engineering and computer science. And I'm very excited to hear from him tonight. Before we turn it over to Andy, I also want to thank Andrew Nui for letting us have the space here at the Nest where we can hold this. And also, I'd like to thank Andy for providing the meals and the food and the pizza and the beer tonight. So that's awesome. So what I'd like, yes, thank you. So what I'd like to do is just kind of go around here first and have everybody just introduce yourself, however you'd like to do that. And we'll start with you, Andrew.
Okay.
Because you're there.
Sure.
We'll turn it towards you first.
Hi, my name is Andrew and Director of Innovation and Startups at the Greater Peoria Economic Development Council. So pleased to have you, Andy, with us today and looking forward to learning more.
Thank you, Andrew.
I'm John Ingalls, and my wife and I run Smiley Graphic Studio here at the Nest. And I do web development, and she focuses on branding and eco-friendly packages.
Awesome.
My name is Dennis Lee, but I don't know how deep down the rabbit hole, but I'm a landlord of the building. I own the building. I've been part of development in Peoria. Recently went back to school for data science, and now I'm an innovation business analyst at OSF Healthcare, where I'm part of an awesome small team that deals with anything innovation. So any doctor, our mission partner, will bring their ideas to our team. If it's novel, we'll file patents and pursue production and eventually commercialization. If it's not novel, we will research and vet out appropriate ideas that we can introduce at the hospital.
Hi, I'm Charles. I'm a front-end web developer at Hi, I'm Ramesh. I'm a student at UFI. I am doing my master's in technology management, but I used to work in IoT for the past 7 years in electronics and building robots and embedded systems. Yeah, here I am doing business program.
My name is Hitesh and been with Himesh. So I work at a startup here called Sense. So we are a healthcare startup and we use a lot of IoT devices and edge computing. So I'm just really interested, excited to see what you have to say about the things.
Very good.
Now we have Ruben online. Ruben, would you like to
Ruben?
introduce yourself, please?
Hi, everyone. My name is Ruben Cummings. I'm the founder and president of a data analytics consulting company here in Peoria called Node-RED Group. Excited to hear what you have to say. Andy, I'm also kind of working on a side project on a low code application. So quite interested to hear what you have to say.
Thank you, Ruben. And one thing Ruben didn't tell you is he also graduated from MIT. So
Hello, great.
Chemical engineering.
all right. So Andy, it's over to you.
Well, thank you all so much. It's a real pleasure to be here. And yeah, it looks like you have a really great venue. This is a really good place to kind of chat about technology. And I think maybe we can have a more interactive session. Please feel free to chime in anytime. So let me first share my set of slides. Okay, can you see this okay? Great.
Yes.
Yeah, so we've been working on this thing for a few years, well, more than a few years now, and we see a lot of very interesting trends in the industry in this space. So I'm very happy to share what we've seen. Just first, from the agenda perspective, just to give you a little bit of overview of what's going on in low code as a whole. For those of you who are not familiar with it, and then we're going to talk about IoT. We're going to talk about how IoT is changing, right? Or how IoT has changed over the past 10 years. We've been doing this thing for over 10 years now. And then, we also talk about IoT, sort of how a lot of analytics and AI are going to the edge. And that's where also low code start to apply more there. I'll use some example use cases. And then obviously we can, just chat on Q&A. So a little bit on the low code, right? This is something that comes from Gartner. You can believe it or you cannot, but the general trend is pretty true. Increasingly companies start not to develop as much code as they used to. And one of the main reasons for that is because all the apps today are in the cloud, right? And DevOps is taking such a big portion of software development, such that a lot of companies out there simply said, that's just very expensive, very time consuming to support. Why don't we do something else to go away from code? So you can see, 65%, 75%, 85%. Certainly, we see a lot of companies adopting low-code type of solutions everywhere, right? One of the downside of that is the word low-code has been a little bit people use it too much. In my opinion, there's low-code and then there's applications, right? Some people even call some applications low-code, but whatever you call it, I think there are many different ways of building apps today, and very often you can do that in a few weeks now. So this is all attributed to what's happening in the low code space. For fundamentally, it's basically low code is basically developing applications with very little amount of coding, right? And if you come from the engineering background, you look at this thing immediately, you're like, you can map this to one of the softwares you used in the past, right? Whether it's MATLAB or or LabVIEW or RSLogix, because it's very much like a functional block programming software, and you can maybe configure parameters for each of the block. Maybe you can double click. Maybe it's hierarchical. You can go down one hierarchy and continue to build. But this is very different, right? From opening a terminal and start to type a Python program. And this is huge. And in fact, as far as we know, a lot of companies simply stop building web applications the regular way. They now rely on local type of platforms to build those applications. And we even do that for our own website. It's very much like working on PowerPoint. It's just super cool, super easy. So we both build low code and we use low code. And as in terms of the benefits, right? It's just very simple to use. It's very modular, and the benefits are not just like enabling your engineers and IT professionals to build stuff that they didn't used to be able to do, but you can get a lot of consistency out of using these tools, right? Because you're building your application on top of a standard or common platform. So the consistency makes it very good if you're a large organization working on many different apps. There's always obviously downside. I have a slide to talk to you about whether upsides and downsides. So as I mentioned, low code is actually something the engineers have been using for many years, right? 50, 60 years or maybe more. And I've pretty much used all of the software here, anywhere from building industrial automation type of systems, right? Those are PLCs, integrated circuits, designing circuits, putting into integrated circuit chips, product test, that's high-speed data acquisition, testing systems, or MATLAB, right? Simulink. And so it's something that engineers are very familiar with. And if you think about the vast majority of companies out there, not software companies, there are a lot more engineering oriented companies than software companies. So this is one of the reasons why low code is catching on. So this is sort of an example of a IoT application if you were to develop it using code, right? So you have to build a dashboard, and assuming that you're building this thing from scratch, right? You have to write your CSS, you have to write your HTML, JavaScript, a lot of frameworks that you have to use to build your visualization. And on the backend side, maybe Node.js, maybe Django. You have to use that to build a backend server. The biggest part is all the DevOps, right? So for example, when we maintain this low-code system, we have DevOps engineers 24/7 supporting that. Anything can go down, right? Databases, containers. So you would have engineers working on it at all times to maintain it. And then, now from IoT perspective, if you're building software at the edge, right? Maybe it's Python, Node.js, increasingly in the past, it's C or embedded C. And again, if you have a large number of edge devices running edge applications out there, you have to do DevOps orchestration. That's also a lot of work. So this is the reason why for many years, IoT type of applications are built by technology companies. They build solutions that are black box solutions, then people use it. And sometimes it's successful, sometimes it's not, simply because, it's built by technology companies, not by the companies that are using them. And it's very difficult to modify anything because of the complexity of this type of systems. So this is an example of a low-code solution. It's actually one we built, running now out there. And this replaces that whole picture you saw before. So you have blocks that represents cloud applications running in the cloud, right? You have blocks where, that represents edge applications. So if you double click this thing, you go inside, you'll see another flow that looks similar, and that's running at the edge, possibly in thousands of devices out there. And you have dashboards, right? That you can, plot charts, tables, et cetera, et cetera. So you got that from cloud to the edge to the dashboards, all together in the same, same view, right? Very visual. You can see how the data flows. Even somebody who doesn't have a lot of technology background can kind of look at it and guess what this thing does, right? Which is impossible to do. Even if you're a software expert, you look at a code base, without spending multiple days on it, you would not be able to figure out what the code base does, right? So this is something we call self-documenting feature. It's self-documenting. And this is based on a very popular open source software some of you may know called Node-RED. I'll explain that, a little bit later. So essentially, if you look at that particular software previously, right? We call it model-based design technique. So, the model is that flow, right? With all the blocks, with all the wires. And that model, there's a place where you build that model in the cloud. And then you can deploy that model to run in those edge devices. And the model is running on top of a traditional software developed system, right? We have to develop the containers. We have to work with the operating system that rides on top of the hardware. So for what we do, there's no difference between what we do versus what another IoT company does. The only difference is that the users get exposed to this model layer, where they can build the flows without having a lot of knowledge of coding or DevOps stuff like that. So in my mind, right, the reason we went down this path is because from the beginning we said IoT is really not a software problem. It's not like building a software application and use it. IoT is a engineering problem. It's a system problem. You have to understand what's going on with the sensors. What are the meaning of those data? What do you want to do with those data? So it's very much an engineering system, not a software system. If it's an engineering system, then we know that low code has been used in engineering for decades and decades, right? And engineers don't care whether it's Python or Node.js, right? Unlike our software developers who argue, incessantly about which is the best software, programming language, engineers just want to get their solution done, right? So you just wanted to use a software, build your solution, and do whatever it needs to do. And also a lot of engineering solutions require that very rapid iteration, right? So because, when you get data from IoT type of systems, you actually, most customers don't know what they can get out of the data. So there's a lot of iteration, experimentation that's required to optimize eventually what they figure out. So that rapid iteration capability, of low code is very advantageous, right? So finally, if you look at all the companies we work with, chemical companies, oil and gas type of companies, all the users are engineers, and they know exactly what they're looking for in the data, which we have no idea, right? So we sometimes look at the data that customers have, try to help them to pinpoint problems. I mean, those are so domain specific. There's no way that either us or any software engineers will be able to understand what those data do. So we got to enable the domain experts, the engineers, to be able to, work on their own data. So that's one of the things low code does very well. So this is a chart of sort of, low code versus full code. And I don't know if you can see it if you sit far away, but I'll just quickly summarize. Low code typically targets domain experts, not software developers like what full code does. It's very fast to develop applications in low code versus, takes, long time to develop a real software application, right, in full code. It's very easy to train engineers to use a low code software. It doesn't require a lot of expertise. But, on the full code side, it requires very strong software developers to build good software. And on the low code side, low code solutions are very easy to maintain. They're self-documenting, while a software code base, it's very challenging to maintain, right? But there's downsides to the low code side, which is why many people don't like it, and that is okay. They can always choose the full code path. One of the biggest complaints we hear is that on the low code side, they don't have control over the underlying technology, right? So imagine that you're building something from scratch in Python. You control every line of code. So you feel comfortable that you know everything you're building, right? But with low code, you're using somebody else's software. Is that really robust? Is that really reliable? So a lot of software developers in particular are feel uncertain about using a low code platform. But for us engineers, if we use something like MATLAB or LabVIEW, we don't care. We think it's fine, and we don't care what's really inside those software packages, right? We use them to build stuff on top. From that perspective, engineers are usually accepts low code much more. But the other thing that I tell people is that even if you are a software developer, do you really have full control over everything, right? So for example, if you use like a framework like Node.js, you are just using all the packages available out there. Does anybody actually go into those packages and examine what's going on there? Nobody does. So it's not exactly true that when you're building full code software, you have full control over everything. You just don't have time. to go through all the packages, right? So that's, you know, one of the things I usually say. Another complaint from people is that low code, you know, tends to have limitations on capabilities on what you can do. And this one is absolutely true. There's no low code software that targets everything, right? If it's a programming language, then it's very general. You use it to build anything. But low code is not like that. Low code software is always like, you know, targets a particular space. That's why low code is kind of in between like a software application and programming language, right? So for example, there's low code software specifically building web apps. There's low code software specifically building AI, low code software specifically building IoT. You're not going to have a low code software that can do all of those things because the fact that you're abstracting away all the complexity, you're also putting limitations on what it can do. But then it just serves those purposes, right? So it depends on what you want to do there. Obviously, you know, most low code software out there are commercial. But again, the reason you know people use it is because you want somebody else to take care of the infrastructure, right? So it's not necessarily you know, a real negative there. So in summary, you know, if you wanted to do low code, if your objective is to sort of build the application very quickly, you don't care about the underlying technology, you wanted to, you know, be able to make fast changes, you wanted to be able to, you know, apply your domain knowledge, that's what you do on the low code side. And if you wanted to control your complete code base, obviously you kind of have to move over to the full code side, right? So that's sort of you know, a little bit of a elongated explanation of the difference between the two. Now let's talk about IoT, right? So IoT has changed a lot over the past 10 years. We've been working on it. When we started out, I think it was 2009. I don't think the word IoT was out there very much. We were building these things called wireless sensor networks, basically very low power nodes to do detection. And at that time, IoT simply meant, you know, you're trying to detect some kind of an event. You know, something got opened or closed, or there's too much gas level, temperature is too high. And so you have these little data packets that doesn't happen very frequently. And you just deliver it when there's an event. And you do very little processing at the edge because the processing power is very low, right? I remember the first product we built, we were using this 8051 microcontroller, which you may or may not know, that had only 16 kilobytes of RAM, right? So there's not much you can do with 16 kilobytes of RAM. So the main thing you do at the edge is basically just gather that data and send it to the cloud and just let the cloud take care of it. You know, dashboards is IoT 1.0, and those solutions tend to be bespoke solutions, black box solutions, very difficult to use. You know, 10 years later, we're dealing with huge amount of data coming out of edge, right? Some of our customers are producing, you know, close to 100 gigabytes of data per day. So with that much amount of data, you really have to be able to have very good algorithms, automated algorithms to get value out of those data. And the processing power is a lot better. You know, I mentioned 2009, our first product, 16 kilobytes of RAM. And right now, pretty much everything we use have at least 2 gigabyte of RAM, you know. So even in the 4 years where we were developing this low code solution, the standard edge device memory went from about 256 megabytes to about 2 gigabyte. And it's going to continue to go up, right? So the computing power at the edge is going to keep increasing. So you can do a lot more things. And because of that, and because of the huge amount of data we're generating, there's increasingly more and more analytics and AI that happens at the edge, not in the cloud. And the other thing is that I think a lot of customers we talk to, they don't want to use bespoke solution anymore. They want something that can handle the entire system, that can, you know, support different type of protocols, different type of software. And open source is not something the industrial sector is very, it hasn't gotten there yet, but we definitely see that people start to want more open type of software systems. So that is, happening today in the industry. So in terms of what we look at it, it's almost hard to call today's edge systems IoT anymore, simply because when we say IoT, people think about very connectivity, very little amount of data, right? And if you look at IoT 2.0, really it's very much a distributed data system that fits into something called the modern data stack. So the modern data stack is the data pipeline, data warehousing, and business intelligence type of software, including like visualization type of things and AI type of things. So the goal of IoT systems today is about making the data usable in this modern data stack, right? Converting raw, inconsistent physical data into contextualized, meaningful data that you can throw into big data warehouses, and now you can use BI software to look at it. Obviously, the other component is you're also doing a lot of stuff in real time too, not just sort of go through a database. But essentially, I think the industry is changing. It's changing in a way where sort of there's this common data framework is being developed across the enterprise companies. Both the enterprise type of data like marketing, sales data, but also the industrial data. So I mentioned that we use Node-RED as a sort of the software we're based on. For those of you who are not familiar with it, I encourage you to play with it. It's open source. You can get it from the internet. You can install it, and essentially it's sort of a functional block programming type of software. There's a set of available nodes. They call it nodes, basically modules. You can drag and drop it into a canvas, and each module can do a certain thing. And then you connect them by wires to flow data from one module to another module. So you can accomplish a fairly sophisticated task, right? There's over 3,000 modules that's already developed. So it supports almost all the common industrial protocols. You can, do data transformation, contextualization, et cetera, et cetera. It's pretty popular. It's pretty useful to try. It's pretty easy to use. So, a little bit about what we do, right? Specifically, in this case, we make something almost like a distributed Node-RED software. Because what we see is that customers have hundreds and thousands of devices that need to run this type of data flows. And if you just have a software like Node-RED that runs in one device at a time, imagine if you make an update. How are you going to push the update to the hundreds or thousands of devices, right? So that's pretty much impossible with a vanilla Node-RED. So what we've done is we built a layer sort of on top of Node-RED, and basically you can associate your physical edge devices to those blocks. For example, you can associate, a couple hundred, say, PLCs, programmable logic controllers to a block. You can associate another set of edge gateways to a block. You can associate another set of industrial PCs to another block. You can route the data between those different blocks by just simply drawing wires. And you can obviously also define blocks that run in virtual machines in the cloud. So in this environment, this data flow, you see sort of your complete system. Some of it is running at the edge, some of it is running in the cloud, dashboards, et cetera, et cetera. And that enables you to build large systems. And every system that we deal with is very large systems, right? Imagine a assembly, like a manufacturing plant, right? You may have 50 of this controllers, on the line, getting data. And imagine oil and gas, right? You might have 2,000 PLCs out in the field controlling different things. So this type of distributed system allows you to essentially distribute code down to those devices and run there very efficiently, very fast, right? You can obviously build this full code also, but it would take software development teams a long time to do, and so that's a trade-off. So let me speak a little bit about AI. Interestingly, we work with a lot of AI partners. We don't do a lot of AI ourselves. We work with a lot of AI partners that provide all sorts of solutions at the edge. One of the, so when you build AI, what you do is there's quite a number of low-code model training type of software. For example, there's a number of very good ones if you want to train, machine vision images. It's just mind-bogglingly simple, right? Let's say that what you want to do is you wanted to train your machine vision model to recognize whether a valve is open or closed, right? What you do is you go to your valve, you put it in an open position, you take a bunch of pictures, right? Then you close the valve, you take a bunch of pictures. You go to one of this low-code model training software, in the cloud. You open it up, you set up a folder called open, you set up a folder called closed, you threw all the open valve pictures into the open folder, you threw all the closed valve pictures into the closed folder, click train, a model comes out. Now you export the model down into your software. Now you can recognize whether a valve is open or closed. It's that simple. And there's other software that can sort of work with numerical data, right? Not necessarily images. You load a bunch of numerical data in there. It allows you to bucket it. Depends on whether it's normal or not normal, and then it trains the model for you. So even though AI is very complicated, machine learning is very complicated, today is getting so easy to do these things. But here's what so a lot of companies are building AI, right? Here's what we find. They find as soon as they get to the end customers, what they find is that in particular in the industrial space, the end customers can have their data, the input data that needs to go into the AI. They can come from a lot of different sources and a lot of different formats, right? For example, they could come from sensors or Pi historians or increasingly MQTT endpoints. And so for each customer, the AI solution provider has to basically build some custom code to handle that very customized input data processing, right? Similarly, when the AI results comes out, say if it's a machine vision manufacturing, detect manufacturing defects, right? That AI result is not the end of the application. It's just the beginning of the application. Okay, now the customer knows that there's a defect. Then what, right? The customer may want to, send a defective image into a database. They may want, to write a few, descriptions on what happened, so to keep track of it. Maybe they want to send it over into their ERP software to trigger something. And every customer wants to do it a little bit differently. So again, there's a lot of customization on the post AI application part, right? And we actually work with quite a number of AI companies where we provide that low code component so that they can use the low code to process the input data from wherever the data comes in with whatever format. And then they also route the AI results back into our software. And so they can do, very customized post-processing. So that's sort of, how the two components go hand in hand together. We are also now start to introduce this type of software to the end customer. So the AI provider doesn't even want to deal with the customization themselves, right? They want the end customer to be able to very quickly get the right input data into the AI and do whatever they want on the output side. So when we talk about edge AI, edge analytics, edge computing in general, today pretty much the majority of companies are aligning on a very similar architecture. So typically customer would have a cloud hub, right? And that's where you have all the cloud orchestration management stuff there. And there's also a edge hub. That's where you can deploy containers typically down to the edge. You can have many containers, and usually there's a data bus that can communicate different data among the different containers, different container applications. So this again is very different from IoT 1.0, right? IoT 1.0, you have one application, you build it on your edge hardware. It's very inflexible. With all that power, the new edge hardware is providing, everybody is building multiple apps at the edge, right? Many AI apps, many analytics apps, and the data bus ties all the different apps together. So one of the things we do is we tell the customers that if you don't want to build your apps in traditional full code, why not use our software to build a low code flow, data flow, deploy down there as a container, and that allows you to very quickly deal with the data that's coming in, process your data, get it ready, send it over to your AI through the data bus. So we have quite a bit of success here because there are many larger companies that are building this type of platforms, but they find that it's very hard to find a lot of expertise to build those apps, and low code definitely reduces the barrier to doing that. So some applications, right? So the applications are also changing. In the past, like what I mentioned, little devices, one data packet once a week, something like that. Today, we're dealing with over 100,000 sensors, per each plant. We're automating the way to detect through, by working through data to detect which sensors are defect, right? Whether the values are stuck or if they're miscalibrated. Because with such huge number of data sources, there's just no way you can figure out what's working, what's normal, what's not normal manually, right? Everything has to be automated. And eventually, what you want to do is you only wanted to produce the consistent high quality data to deliver that to data warehouses, to the AI algorithms, et cetera, et cetera. Similarly, in manufacturing, when a manufacturer have, possibly a few hundred different vendors that provides all sorts of manufacturing equipment, every equipment today is emitting data in its own unique format. And it's impossible for the manufacturing company to be able to use this data just because all their vendors have their own different data formats, right? So you need, a way to be able to convert all the different vendors' data into one or a few common data format. You wanted to validate all the data because junk data leads to junk results, right? When you use it for BI or analysis. So that's another thing that the industry is changing, from simply collecting data and using that to validating and filtering out the bad data, so that your data warehouse contains consistent, high quality data. So this is an example of how you do data cleansing. And essentially, this actually does come from a real type of data. And, in low code type of way, you can just drag and drop different blocks in there. And we do have packages that there's different ways to cleanse the data. But I think the biggest benefit of doing this type of data cleansing is that it's very, very flexible. You can add different blocks any way you want, right? Data cleansing, what we typically say is that it's a very custom application, because depending on the particular content of the data, you clean it in a different way, and therefore domain experts have to get involved in data cleansing. And so we enable the domain experts to be able to do data cleansing type of work on huge amount of data. Obviously, there's traditional applications where you can build low code and deploy to it. This is one of our earlier applications, but it's super cool because, you're talking about hundreds of this type of controllers, monitoring chemical type of usage, and it's pretty sophisticated programming side where it monitors over 100 different type of parameters. And it was really done by one engineer. One engineer was able to build the whole thing and deploy it and grow it. So that's something that I think, what we wanted to accomplish from the start. Machine vision is another thing that we can add into those edge gateways very quickly. And, we don't have a lot of machine vision application on our own, but we have partners who provide really good machine vision modeling and stuff like that. So, I think the idea is basically now you have this low code platform, you can do the more traditional, relatively low data rate type of processing at the edge, but you can also do fairly advanced AI, AI and very advanced data processing that handles very large amount of data. And when the IoT is going in that direction where it's huge amount of data, huge intelligence, I think most companies can no longer spend 90% of their time building the software infrastructure anymore, right? They wanted to spend 90% of their time building that application as quickly, as simply as possible, and very effectively. So I think that's where, low code is being increasingly helpful in the IoT world, because the IoT world has changed, right? It's much more about data today. So that's the presentation. I'd love to get some feedback and questions.
Yeah, I have some questions. So thinking of low code and edge devices. Now, yes, so there is capability of building applications by the the concerned people instead of you giving to some software developers, things like that. But how do you where do you say there is a compromise between the efficiency, because the edge devices are looking for low memory like code, versus like when you use low code, how do you actually solve that problem of you need to use low memory, there is resource constraints in the edge devices?
Yeah, that's a really good question. If I understood it, what you're saying is that a lot of edge devices are resource constrained, right? And the low-code software typically use a lot of resources, so it's not necessarily as efficient for edge devices. Did I get that right?
Yeah.
Yeah. So I think if you look at IoT, I would say today there's probably two types of edge hardware. If I could generalize it a little bit. One type is like the microcontrollers that we used to deal with, right? Even those have gone from maybe 16 kilobytes of RAM to something that's on the order of tens of megabytes of RAM today. And so you can do a lot more on there, but still it's very resource constrained. Something like Node-RED doesn't run on it. We cannot support those type of devices. Doesn't mean that we cannot over time, but right now we can't. So for those very constrained, low power edge devices, you still very much develop in, something like an embedded type of environment, right? And maybe it's hex code, or it's a very stripped down OS in those devices. The stuff
sorry, that's where you're going, but like even with devices like Raspberry Pis, so they still are they are running on Linux, but they still have those resource constraints. It also depends on the application versus the device that you're choosing. So business decisions will be made on, okay, so I have this kind of an application, so I will use this particular kind of, you can use like something like Intel NUC or something which is more powerful. But so how do you say that low code versus, okay, you need to use more processing for the same application and use low code, whereas you can invest in software development and have more control over the code, but use low cost, for less powerful devices. So where does that balance? How do you bring that balance about?
Yeah, so something like Raspberry Pi actually has a lot of power, right? Raspberry Pi 3, let's say, has like 1 GB of RAM, right? And something like Node-RED requires about 100 megabytes of RAM. So you still got plenty of RAM left over to do a lot of processing. And today's industrial gateways are somewhere between 1 GB of RAM to 2 GB of RAM, and obviously there's more powerful ones, even 4, 8 GB of RAM. So hardware is not becoming hardware. So if you're in the IoT gate, if you're in the edge gateway space, then hardware is no longer a constraint, right? So when hardware is no longer a constraint, what you want to do is you want to save people's time, developers' time, and because time is very expensive, all right, especially in this country. So now the low code allows you to develop things really, really fast. So you're basically trading off the hardware with easy development. And that's the same as sort of why people are using even Python JavaScript today. Python JavaScript, they're at least 10 times slower than C. Why is no one developing C web servers? It's because it's so much easier to develop in JavaScript such that more people can do it, right? So it's the same reason, like we're using trading off the hardware resources for ease of use.
Thank you.
Yeah.
So I have a question. So if you have the low code, and I
Hi, Lindsay. Welcome to the IoT meetup.
Hi there. So the question I have is, if you're going through and you have the low code.
I'll be done. I'll be done soon, okay?
But why do I have to be alone?
You just be there for 20 minutes. I'll be back.
No, not
Come on,
20
come
minutes.
I'm sorry, Shannon. What was the question?
Yeah. Oh. So my question is, because I've had this, as a software developer before, where you'd have something that's more of a low code, and it'd do good with some abstraction, but you might want to have more control at a certain piece of it. So let's say there was a specific widget you want to do. So my question is can you take one of the pieces as low code and build your own container and your own C code to go on there, so you have all that control for that one piece that you need, and then snap it back in?
Yeah, you can. So even in Node-RED, for example, you can write your own code. So we write our own code if we want to build something complicated. For dashboards, Node-RED, you can do drag and drop, but we write our own HTML and CSS if we want something that looks better than what Node-RED can do. So yes, I agree. Like for people with more coding skills, Lindy, this is a serious meeting here, okay? For people with software skills, like some local platforms does offer that extension.
Can I ask a follow-up question? So do you foresee that there's a situation by which it's developed, implemented, tested to some point of stability till it gets to release X, and then is there a way to convert that into full code because there's specific devices, edge devices that might need that level of granularity? Do you see that happening? And if so, what would that look like?
Yeah, so I think one of the things a lot of developers complaining about low code is they don't know how to test it. And I think, first of all, the low code software provider has a responsibility to test the underlying infrastructure, right? All the code that the low code is running on top. Otherwise, there's no point, because if the software provider cannot guarantee their underlying technology infrastructure is reliable and stable, then this whole thing is not going to work. So the remaining question is basically assuming that you can trust the underlying technology infrastructure. How do you test what's on top, right? And when you have this kind of flow programming type of software, in fact, testing is very different. And because we used to use this type of software a lot. You can build a test environment that's very visual, right? So you like your software, your local software, the whole thing by itself, you can build it as a module. And then you can have test sources on the input side. Then you can have stuff on the output side to catch the output, then verify that is okay. It's actually a pretty different way to do testing, but it's very visual. It's much simpler than all the tests that software developers do. I do agree that you have to be able to test very effectively, but in the end, even low code runs as full code eventually, right? That low code is just graphical for the user, but it gets converted to full code to run.
Got it. Thank you.
And when you first began, you mentioned that the Node-RED has over 3,000 libraries. Are those user submitted libraries, or is it the development team developing as they find a need?
Yeah, so it's a combination of both. There's probably, I would say, several dozen fundamental nodes that's developed by the core team. And those are very, very stable, right? The rest, 2,950 are developed by all sorts of, users, and some of them are really bad, right? So you can't just grab a node and expect that it's industrial grade. But that's the same as any open source type of system, where you can have high quality stuff and you can have low quality stuff. So Node-RED, one of the things they've done recently is like a rating and ranking system on the packages people contribute, right? So for example, there are some user contributed packages that are really good. We know those guys, they know what they're doing, they know how to test. So they're very reliable. And then there are some that you have no idea. So that's one of the complexities of this type of open source software. But that has always existed, I think. As long as the software is open source, you're going to have some really bad packages contributed by people who mean well, so.
Follow-up question here regarding open source. How do you address the issues of any sort of malicious code in some of the packages? Because, is there anybody checking packages for sort of backdoors?
Yeah. So Node-RED is built on this thing called Node.js, which is probably the most popular open source software framework out there, because Node.js is used by like 98% of all Fortune 500 companies for building web applications. And there's a lot of automated software behind the scene to check the risk validity of all the software. But even with that, it's very difficult to catch everything, because packages are contributed, right? There's this famous story a few years ago, I don't know if you heard. There's this very popular package used by millions of people running on millions and millions of machines. It turned out whoever contributed that package put in a Bitcoin miner inside. So essentially all these Fortune 500 company servers are mining Bitcoin for him, and took a long time for people to figure it out. So definitely there's that downside of open source, but on the other hand, Node.js has like 200,000 packages that can do everything. And certainly if you have a small development team, is really a great platform to get started to build things quickly, right? So that's a trade-off. Yeah.
Awesome, thank you.
So question, so if somebody wants to use this, where do they go and how much does it cost? And we have a lot of people here who are doing their own startups, and they might want to do something that can actually use controllers and those types of solutions. So where do they start?
Do you mean our stuff or generally?
Like
Sorry?
if they wanted to use your software, where would they go to get it? And how much would it cost? And how do they download
Yeah.
it?
So for us, you know, we have a free version of the software people can use, and forever. You know, limits you to a couple devices that you can deploy code to for you to test. But if anybody is interested, just email me, and you can get an account. Then you can, you know, log in online, and you can use it, play with it. In terms of business model, our default model is typically like is based on the number of what do we call instances. So the instances are the number of containers you have in the cloud plus in the edge, right? So let's say if you have, you know, 5 of this accounts in the cloud that are doing different projects, that's 5 containers. You have 1,000 containers running at the edge, you know, which can be 1,000 edge devices, or could be 200, because increasingly a lot of the customers are running multiple instances in the same hardware, right? So we count that up, then we say this is how much it is for you. It's a fairly common model, I would say, for this type of system and software.
So in other words, they have to, it's kind of dependent. It's independent on what you're using, and they need to contact you to kind of get the pricing. Is that right?
So we're trying to make it as independently as possible, but we have not gotten there. So for example, right, we have customers, they build systems where they have 1 device per solution. And let's say, you know, they sell their solution $5,000 per device, right? Then they can pay a lot for our software. But then we also have, you know, customers who pay who charge $150 per device for their customer, right? So in the end, we kind of have to talk to the customer to say, okay, you know, how much can you afford? What's reasonable for you? What is the volume? Yeah, so it's not like, you know, enterprise Gmail, $6 per user per month. Yeah, so it's quite a bit more complicated than that.
Okay, and if somebody were like doing a startup and they just wanted to play around with it, I mean, is there just like a no fee one for somebody?
Yeah. So we have a free version. You know, it's a cloud software. So you log in, you build your flows, then you can deploy to the edge devices. You can either sign up on our website, or you can just email me, and we'll just, you know, send you an email where you just log in and you can play with it just for fun, you know.
Okay, and did we get your email? Did you have a slide in there? I mean, I have his email. Wondered if not, we can make sure.
Was it in your first slide, Andy?
Yeah, so let me put that up.
Let's put it one more time
First.
up there. I did actually had a use case I want to run through. I heard from somebody in this room today. I'll see if your software can help them.
Yeah. Oh, that's great. So I don't have the email here, but it's andy.wang. So Wang is WANG. So andy.wang@prescientdevices.com.
Okay, there you go.
Awesome.
So you can just email me or go to our website, and we have a form. You fill it in, and we can send you an account. Yeah.
Perfect. So here's a use case. I just wanted to see if your software would help do this. So let's imagine that you have a retail store and you're selling some beautiful t-shirts, and you wanted to basically see the traffic pattern, how people are going through the store, and you wanted to try to get some insights out of that, so that you could say, okay, I know that this display maybe is drawing more people to it, or I may see a pattern where I want to try to collect things together to be able to offer them, if I'm putting that correctly. So would your software be able to do a computer vision? Would they be able to, you know, snap some things together and be able to get some insights like that?
Yeah, so we have quite a number of customers who do machine vision on the platform. And usually what they do is they are responsible for building the model. And then, you know, they use ours to deploy, to manage, and also to put all the application code around the machine vision, right? The other thing is that there are a lot of online places where they offer pre-built models. I don't know in this case if there's a model, but in many cases, there's already a lot of models available online. You pay a little bit of money to use it. So in that case, you don't even need to build models. You just kind of use a low code to put the application logic together, deploy down to your stores. So definitely, It's in the same sort of space that we serve, but we would have to understand exactly what are the requirements for the machine vision model to see how we could recommend what's the best way to do it. And right now I don't completely understand what you need to detect in the machine vision model yet. Yeah.
Okay. All right. Thank you.
So building on her question, would the model present a heat map maybe of the floor plan or the trafficked areas by time or?
Yeah.
Yeah.
Yeah. So if you when you say heat map, if you mean like detecting how many people are at a certain location at a particular time, right? That's pretty easy. I believe there's already a lot of models that help you to do that. So you can probably pull a solution like that together pretty quickly.
And then to another question on that, saying, are you able to use security camera footage for your vision interpretation, or do they need to be standalone?
If the security cameras, if you can somehow get those video streams, then sure, then there's no problem, right? Yeah. You don't need special cameras, but you need those cameras you need to at least to be able to get to the video, right? If you can somehow get the video, then you can process it.
Interesting. Any other questions in the room? Okay, this has been fascinating. I mean, honestly, it is very interesting, especially, as you look at all of the automation that's going on around the world. I work in Industry 4.0, a manufacturing piece of that, and just the amount of adoption of automation is growing, and the need for that automation, especially when you're looking at all the challenges for the labor shortage to all the constraints and rising prices and people needing to get the efficiencies in the factories, improvements there. So this is I'll be interested to see how this grows and gets adopted.
Yeah, it's definitely a very interesting space. And the analogy I would use is that if you look at the automation space, right? It's all engineers who use PLCs and PLC software to build automation systems, right? But it's very hard for the same engineers to build like very customized, effective IoT solutions, simply because all of a sudden you require so much more software framework in order to do it. Our engineers can program some Python, but it's a different thing from programming Python to programming all these containers that have to be maintained and updated over time. So our goal really is to build something just like the PLC software that engineers can use everywhere. Yeah.
Very good.
So these blocks, what language are they running on? Like, what is underlying code that is running on? Which language?
I'm sorry, I didn't hear it clearly.
Oh, okay. These blocks that you're talking about. So what is the underlying language?
What's the underlying language? So by default, it's built in Node.js, which is based on JavaScript. But certainly you can also embed any other programming language in there. So Python is pretty popular because a lot of people know Python. C is used a lot for lower level IO interactions. But then above that, you can wrap it in JavaScript as a Node.js type of package. Yeah.
Great. Okay. Well, I think we are a little bit past 7 o'clock. I do want to say thank you very much to oh gosh. Andy, yes, I keep on saying Andrew, I'm sorry. Andy, it's a touching girl, but thank you very much, Andy. I appreciate you coming and talking to the group. I want to thank the group for coming and participating tonight. And we'll be on tomorrow morning and listen to you at the coffee talk. So thank you.
Sounds great. Well, thank you all. Thank you all very much. Really appreciate it. And if you have any questions, let me know. Love to stay in touch. Love to visit you guys. When we're able to.
Yeah, we'd love to have you here. Absolutely. Okay, thank you guys.
Thank you.
Thank you.
Thank you. Bye.